Okay, so first video on ionic bonding, so we'll call it Ionic Bonding 1 originally enough. Make sure you have your periodic table in front of you because we're going to be referring to it throughout. So, ionic bonds are the bonds that form when metals react with non-metals. And when this happens, metals lose electrons and the non-metals gain electrons. And when a species loses electrons, we refer to that as oxidation, which might seem a bit strange because we don't always have oxygen in the reaction, but that's referred to as an oxidation reaction when you lose electrons. And when something gains electrons, that's referred to as reduction. Now, in a reaction like this, where the metals are reacting with non-metals, the metals are being oxidized, the non-metals are being reduced, and as the two processes are happening at the same time, we call this a redox reaction. So a redox reaction is where oxidation and reduction are going on at the same time. And you need to remember the definitions for oxidation and reduction. So a popular way to do this is to remember oil rig. And that stands for oxidation is loss, and over here reduction is gain. And you might be wondering, well actually why do the metals lose electrons and why do the non-metals gain electrons? So why do they do this? Well, it's all about trying to get elements or atoms to achieve their life goal, and their life goal is to have a full outer shell of electrons. Now let's take for example a metal like lithium. Lithium is in group 1. Lithium reacts beautifully with chlorine, a non-metal. And let's have a look and find where chlorine is on the periodic table. Towards the right hand side, it's in group 7. Now, in order for lithium to get a full outer shell, it can do one of two things. Let's draw the lithium atom. Okay, so we've got 3 electrons in lithium. We've got atomic number of 3, and there's 1, 2, 3. Now, in order for lithium to get a full outer shell of electrons, it can do one of two things. It could either gain another 7 electrons to fill that outer shell, or it could lose 1 electron, and therefore the shell below it would be the outer shell, and that's already full. So which is easier, lose 1 or gain 7? It's obviously lose 1. But if it's going to lose an electron, it needs to find somewhere for it to go, and this is where chlorine comes in. Chlorine, and I'm only going to draw the outer shell of chlorine, has 7 electrons. It's in group 7. So that electron from the lithium leaves the lithium and is added to the chlorine atom. So we now have, here's my lithium and here's my chlorine. And I need to show where the electron has joined to the chlorine. Here it goes. And because the lithium has lost an electron is negative. So as we've lost a negative, what's left behind is overall positive. And the chlorine over here has gained that negative particle, it's gained that electron. So the chlorine itself is negative. Only one negative, but we must make sure we mark the minus sign on. So that is your first cross and dot diagram for an ionic compound. And I must admit, when students are confronted by this in an exam, when you've done all different types of bonding, you must first look at what type of bond you think it's going to be. And if I'd asked you straight off the top to draw the cross and dot diagram of lithium chloride, you must look at it and think, ah yes, we've got a metal joined to a non-metal or bonded to a non-metal, therefore it must be an ionic compound because we've got a metal and a non-metal. Now our definition of ionic bond can be summarized as E a Bocchi. That's the phrase, or the mnemonic I remember, Iabocchi. And Iabocchi stands for the electrostatic attraction between oppositely charged ions. So you can see here we've got an ion, which is plus, an ion here, which is negative, and these two will attract. And they'll actually attract very strongly because of their opposite charges. So, let's have a look at drawing some cross and dot diagrams for other ionic compounds. Here we've got sodium and fluorine. So sodium has 11 electrons. And if we drew all the shells for sodium, that's what it would look like. And that 1 electron there. Fluorine only has 7 electrons. Actually, I'm lying. And those of you looking at your periodic table should be able to tell me if I got that wrong. Fluorine actually has 9 electrons. It's in group 7, but it's got 9 electrons, so it's got draw crosses for this, 1, 2, and then 1, 2, 1, 2, 1, 2. So what happens when I put the sodium with the fluorine? Well, the sodium, because it's the metal, loses the electron, and the fluorine, because it's the non-metal, gains the electron. So here's my sodium. I'll carry on drawing all the electron shells just because I've started that way. And over here we'll have my fluorine. Cross, cross, that's the inner shell. And here's the outer shell. So the fluorine has gained the electron from the sodium. Here it is. The fluorine now has a charge because it's gained that electron, so it's minus, and the sodium becomes positive because it's lost that electron. Now thus far we've only looked at group 1 metals reacting with group 7 non-metals. What about changing it around a little bit? Magnesium is a group 2 metal and oxygen is a group 6 non-metal. So magnesium, if we have a look at the periodic table, it's got an atomic number of 12. So here's magnesium. I'll draw the inner shells to start with. Not quite sure why my electron shells are so oval in shape, but here we go. And because it's in group 2, we've got 2 electrons in that outer shell. We've then also got oxygen, which has got 8 electrons.
That's all right. You're all right doing the lights and stuff when you're done?
Yeah. Sorry about the interruption. I'll carry on now. So magnesium group 2, 2 electrons in the outer shell. Oxygen, 8 electrons. So let's draw those. 2 electrons in its inner shell, and then 6 electrons in its outer shell. So what happens when we put magnesium in oxygen? Now you've done this in practice, you do this quite frequently in the lab. Magnesium reacts very readily with the oxygen, it burns with a bright white light. And what's happening is that those 2 electrons from the metal are being lost. And where are those 2 electrons going? Well, they're being picked up by the oxygen around here. So what actually we form there's my magnesium, and here's my oxygen over here. Oh, I keep drawing my dots, but oxygen, I've said it's cross. And let's put on those 2 electrons from the magnesium. We now need to put our charges on. Well, magnesium lost 2 electrons, so it becomes 2 plus. And oxygen gained 2 electrons, so it becomes 2 minus. And you might be thinking here, well, you're thinking back to your ionic bonding. definition, Iabocchi, you've got 2 plus and 2 minus now attracting. So that's clearly going to be a stronger attraction than between 1 plus and 1 minus. Let me show you a couple more cross and dots. Okay, here we've got magnesium and fluorine and a bonus arrow in the middle. So magnesium being a metal in what group? Group 2. So now I'm just going to take a few, not shortcuts, but do it as you'd probably do it in the exam, just showing the outer shell. So here's my 2 electrons on the outer shell of magnesium, and here's my fluorine. Fluorine being in group 7. You'll probably spot now that magnesium needs to lose 2 electrons, but fluorine can only actually hold 1. And the way we overcome this is by having 2 fluorines. So 1 electron from the magnesium will go to this fluorine, 1 electron from the magnesium will go to the other fluorine. So let's have F dot cross negative. Okay, that's a fluoride ion. And we've got 2 of them, so we can probably write 2 times F minus. We also need to talk about our magnesium. We've not drawn that yet. So here's my magnesium, and we know because we've removed that electron, those 2 electrons in fact, that the shell underneath is full. And has a charge of 2 plus. And the final question here is, what are the connections between group number and charge on the ions? So if we look at group 1, 2 and 3, if you look back over the examples that we've used, things in group 1 like sodium, lithium only have 1 electron in their outer shell, so they lose 1 electron and form 1 plus ions. Things in group 2 like magnesium lose 2 electrons, so they form 2 plus ions. Things in group 3, aluminium for example, metals in group 3 form 3 plus ions. But for my non-metals, or for our non-metal atoms, it's slightly different. So let's look at non-metals in group 7. Now non-metals don't lose electrons like the metals do, they gain electrons. So a non-metal in group 7 only gains 1 electron to give it a full outer shell, so has a charge of 1 minus. Things in group 6, non-metals in group 6, need to gain 2 electrons, so they have a charge of 2 minus. And non-metals in group 5, things like nitrogen, have a charge of 3 minus, because they are gaining 3 electrons to form their complete outer shell. And that's the end of this part of the video.